Okay, we're moving on to section 4.8, the quadratic formula. So we want to know, how do you solve quadratic equations using the quadratic formula? So far we've solved quadratic equations by factoring. Unfortunately, a lot of equations are not factorable, yet they do have solutions. So anything that's not factorable, we have to use the quadratic formula as another option to solve it. So here's the quadratic formula. If I have a quadratic equation in standard form, then its solution is equal to this. So it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are the coefficients in standard form. Okay, so all it is plugging those numbers into here and getting your solutions. Now this plus or minus means that we actually have two solutions potentially. Okay. Remember, if I solve a quadratic equations, it's the same as its x-intercepts, and these are parabolas. So a parabola can cross an x-axis in two locations. It could, if the vertex is on the x-axis, it could have one solution, or it could have no solution. Okay, so these equations could have any of that, and we'll see below here in a second how to determine how many solutions we have. But let's just try to use the quadratic formula to solve an example here. Okay, so what I like to do first is, once my equation is in standard form, is to identify what is a equal, what is b equal, and what is c equal. So in this case, there's the coefficient of x squared is just 1, coefficient of the x is 3, and the coefficient, or the constant term, is -2. Okay, so all I have to do is plug those into the equation to solve for x. So I get negative b, so that's kind of like the opposite of b, so it's opposite of 3 is -3, plus or minus the square root of b squared, make sure you put that b in parentheses, minus 4 times a times c all over 2 times a. Okay, now the first thing you're going to want to do is everything underneath this square root. That's where we're going to make our mistakes. If we make a mistake is under the square root. Typically common mistakes are with the signs under here. Okay, so the first thing you got to be careful with is when we square b, no matter if b is positive or negative, we get a positive result, right? So 3 squared is 9. Then I always look at, what's my sign going to be? Is it going to be plus or minus? So this is always minus. So if either a or c are negative, in this case c is negative, I'll have a negative times a negative, it's going to become positive. If they're both positive, then it'll be a minus. If they're both negative, then I'll have a negative times a negative times a negative, so I'll still have a negative there. Okay, so let's see. -4 times 1 times -2 would be 8. So then I rewrite this as -3 plus or minus the square root of 9 plus 8 is 17 over 2. Now at this point I want to look and see if I can simplify this square root down. In this case I can't. There's no perfect square that goes into 17. So I'm going to leave my answer just like this. That's how we want to leave our answers in this section. Now you could figure out what the decimal of square root of 17 is on your calculator, and then you could take -3 plus that value and divide it by 2, -3 minus that value and divide it by 2, and get two separate solutions, and that would be that. You could do that, but in this section for now we're just going to leave the answer in square root form, because that's how the answers are in the back of the book. Okay. Now let's move on down here to the discriminant. So when I look at the quadratic formula, the value under the square root is called the discriminant, the b squared minus 4ac part. And that's important because that's going to tell us how many solutions we have. If b squared minus 4ac is greater than 0, so if it's a positive number like it was in this example, then we're going to have two real solutions, or two x-intercepts if we were to graph this. This result up here is actually two answers. It's actually -3 plus the square root of 17 over 2. That's one answer. and negative 3 minus the square root of 17 over 2. That's the other answer. Okay, so I could actually figure out what that value is if I wanted to, again, if I wanted to use a calculator. So if I have a positive under the square root, two solutions. If it equals 0, if b squared minus 4ac equals 0, then I have one real solution and one x-intercept. Okay, that makes sense, because if this is 0, this whole term, off the screen. If this is 0, the square root of 0 is 0, so this whole term goes away. So I get negative b over 2a as my only solution, and that's only one value. Okay. Finally, if b squared minus 4ac is less than 0, so if it's a negative, then I have 0 real solutions. I actually have complex solutions. And I have no x-intercept. Again, just like in the last section, if this is less than 0, I get the square root of a negative number, and that's those are complex numbers. Okay, so let's look at this one. How many solutions does this equation have? So if I was to figure that out, I would have to get it in standard form. So this 5 has to go to the other side. Okay. Now I don't have to solve the whole thing if I just want to answer this question of how many solutions. All I have to do is look at the b squared minus 4ac part. So let's just do that part of it. In this case, I'm going to write this over here. A equals negative 1, b equals 4, and c equals negative 5. Okay, so when I plug in 4 for b, minus 4 times a, times c is negative 5. So what do I get there? I get 16, and then a negative times a negative times a negative is still minus. I get 16 minus 20. So in that case, it's negative 4. So because b squared minus 4ac is less than 0, I have 0 real solutions. I have complex solutions. Now if I want to take this a step further and actually solve it, let's do that. So let's actually use the quadratic formula and solve it. So, So I'd have negative b, so it'd be negative 4 plus or minus the square root of b squared minus 4ac, which I've done already here, is just negative 4, over 2 times a. Okay, so now this, going back to the last section, I can simplify this square root of negative 4 by pulling an I out of there. So it'd be I times the square root of 4 over negative 2. Well, what's the square root of 4? The square root of 4 is 2. So I can rewrite this as negative 4 plus or minus 2i over negative 2. Okay. Now, because this number divides into both parts here, I could actually simplify this further, and this is going to be 2 plus or minus I, because I divided negative 2 into both parts. Okay, so this is the proper look of the solution there. So that's using the quadratic formula to solve a quadratic equation. Now let's just do one more example right here. Okay, so now this equation is a little bit jumbled, so I got to get everything to one side. So if I subtract the 2x from both sides and bring the 9 over, I'm going to get 4x squared minus 12x plus 9 equals 0. So a is 4, b is negative 12, c is 9. Okay, so let's solve this equation. I'm going to rewrite the quadratic formula. it is. So now let's plug the values in. Negative b, so b is negative 12, so negative of negative 12 is positive 12. B squared is negative 12 squared minus 4 times 4 times 9 over 2 times 4. Let's see what we get here. Negative 12 squared is positive 144. Negative 4, so this is going to be a minus. 16 times 9 is 144 as well, over 8. Well, that's going to be 0. So the discriminant is 0 means I only have one solution. Because if this is 0 squared is 0 is 0, so it just ends up being 12 over 8, which is 3/2 or 1 1/2 on that one. Okay, so there's another example. Let's do one more. This will be a good one to try on your own first. So maybe pause the video, give this a try, and then we'll work through the solution afterwards. Okay, so if I get everything to one side, I have negative 5x squared. Subtract 2x here. It's going to be plus 5x. And then subtract 3 is minus 7 equals 0. Okay. Now, one thing you can do, you can plug these numbers into the quadratic formula as is, or I could switch the sign on everything and basically divide both sides by negative 1 and get a result of 5x squared minus 5x plus 7 equals 0. Either equation is the same. I just like to have my a value be a positive number. It just is easier for me for some reason. So let's just plug this into this quadratic equation here. So negative 7 or negative 5 is 5 plus or minus the square root of negative 5 squared minus 4 times 5 times 7 over 2 times 5. Okay, I'm going to run out of space here, so be a little creative. Slide this down here. 25 minus 20 times 7 is 140 over 10. Okay, so 5 plus or minus the square root. 25 minus 40 is negative 115. Okay, so no real solutions. We have imaginary solutions. So I'm going to factor out the square root of negative 1 out of there and rewrite it like this as 5 plus or minus I times the square root of 115 over 10. That's how I'm going to leave my answer. However, you do need to look and see if 115 can be simplified, if there's a perfect square that goes into 115. In this case, there is no perfect square that goes into 115, so this is considered simplified. And that's how we're going to leave our answers in this section. So that is the end of section 4.8.